So hopefully everybody can see this. So my name is Helen Hawley. I'm from Guru Systems, and today I'm going to be talking about heat networks and looking at a general overview of heat networks, discussing some of the benefits, some of the risks, explaining what they are, and going through some compliance and other information that hopefully will be useful. Guru Systems is a manufacturer and supplier of intelligent technology for energy monitoring and metering. We've been specifically focused on heat networks and been in the industry for about 10 years. I myself have worked in heat networks for about 10 years also. So there's a lot of expertise within the company, which we hope we can share with you. So, what is a heat network? Basically, a heat network is a development which has an individual heat source that serves multiple units. So these can be residential or commercial units, as long as there's multiple units being served by one energy source, heat source. This constitutes a heat network. So this can be small on a single building sort of sized project, or this can be really, really large, serving multiple buildings, or even you can have a central system that serves multiple developments. So potentially multiple buildings at multiple different sites. And this would be considered a large district heating system. The heat source could be anything. It could be boilers, it could be waste to heat, it could be heat pumps, it could be CHP. So the heat source itself isn't important in terms of whether it constitutes a heat network or not. It's more about one source serving multiple units. So, why would you go for a heat network over the more traditional individual boiler situation? Well, heat networks provide carbon savings, and also they are less costly to run than individual systems. The concept here is essentially economy of scale. Larger plant is more efficient than smaller plant. So an individual boiler for an individual dwelling will be less efficient than a large commercial sized boiler, which essentially means that you will use more energy into the boiler to produce the load requirement than you would need to on a bigger system. Also, if you are serving multiple dwellings and you are therefore purchasing more energy, more gas or electricity, you potentially have the possibility of getting better tariffs. Because you're purchasing more, you will be able to negotiate lower tariff rates, and therefore there is a bit of a saving there as well. The most important thing, however, is the way the system is designed. So with a single boiler, typically the system runs on an 80-70 degree output for heating and delivers domestic hot water at 60 degrees. So these are quite high thermal outputs. With district heating or heat networks, typically you will be looking to reduce those temperatures. So you don't tend to store domestic hot water in a cylinder, you tend to supply direct to the tap. And this means that you can lower that temperature to 50 degrees. Also, for the system, you tend to have something which is a large delta T. So on the supply side of the network, or the primary side of the network, you might supply hot water to the dwelling at 60 degrees and you want to strip all that heat out of the supply and return the water back to the plant room at 30 degrees, which means that you're using all the energy that you've put into the network. And it's this efficiency of the system design that allows you to have real carbon savings, and also because the system is so efficient in its energy usage, you save financially on running the system too. So the main differences for the end user would be that with a gas boiler or an electric heating system, they are responsible for their energy supplier. So if they feel they're being overcharged, they can switch to a different energy supplier, and that's something that they look after and they organise and they're responsible for. Similarly, we find that a lot of residents are also responsible for the maintenance and repair of their individual boiler system. Boilers obviously use fossil fuels, and because of this, the government is looking to actually phase out boiler production. So I think in 2025, they are looking to stop production of gas boilers. On the flip side, for heat networks, residents are tied into their energy supplier. There's one heat source that is connected to their individual dwelling, and so this is the system that they are tied to. In addition, they tend not to be responsible for the heat interface unit, or HIU, which is the interface for that individual dwelling to the rest of the system. Typically, the operator of the heat network will retain responsibility for maintaining that heat interface unit. So there's less responsibility for the occupier. Obviously, as we've just discussed, this is a low carbon system, more energy efficient, and because of this, the government has incentives for increasing heat networks within the UK. So whereas boilers are being phased out, heat networks are being promoted. At the moment, heat networks are not officially regulated. With electricity and gas supply, Ofgem obviously is the regulating body. And for heat networks, there isn't such regulation yet. However, the Heat Trust is the energy ombudsman for heat networks. So there is somebody keeping an eye on things. And over the years, there has been a lot of development to make sure that heat networks are designed to a standard and are run to a standard. And actually, Ofgem is going to supersede the Heat Trust and start regulating heat networks just the way it does with gas and electricity in the next year or so. However, there are things to comply with. So there is the heat network metering and billing regulations 2014, which was updated in 2020. And this document details the minimum requirements for monitoring and metering a heat network. This document actually applies to any heat network, so not just heat networks that are to be built, but also any heat networks that currently exist. This document basically says that where feasible, you need to install an energy meter at the point of consumption. So each dwelling should be individually metered. That's pretty much as far as it goes. There is also the CP1 Code of Practice by heat networks. This document goes quite a bit further than the regulations, the heat network regulation. This document describes that you should be looking at not just the end user consumption, but you should also be monitoring within the network itself. So at the plant room, at the heat source, point of the heat source, and also in the network piping, risers and so forth. It also talks about something called acceptance testing, which is fairly new within the industry. And this is about making sure that you have a baseline for the best possible functionality of your heat network. So once you have a development and it is built, you test your system to see if it matches its design parameters, or how closely you can make it match its design parameters. I'm sure we're all familiar with, design and what is actually built not always being the same thing. But with acceptance testing, you can get a good baseline for the most efficient function operation of your heat network. In addition to this, there are some planning requirements within the UK. So the BSEEN document for the Greater London Authority planning policy is one of these. And basically this indicates that where possible, heat networks need to be installed. It also talks about the need to monitor these heat networks and record the data for a minimum of 5 years. So again, this is going further than the heat network metering and billing regulation, and suggesting that it's not about end user consumption for billing purposes, but it's actually looking at the performance of the network and recording that data over time. So as you can see, moving forward, regulation is going from let's just see what people are using to let's see what the network is doing. And as we move forward, you will see why. So these are the sort of three main risks with the heat network. If you have a credit billing situation on your heat network, then obviously there is a certain amount of debt risk that is to be taken on. In addition to the potential for debt risk, you typically would employ a metering and billing company to administrate the billing for your heat network, just like you would employ operations and maintenance company to make sure that the building runs. You would get this metering and billing company to take on the administration of the billing for the heat network. Some of these companies have their proprietary monitoring systems, and this can mean that housing associations and local authorities who own the heat network get tied in with that metering and billing provider, because the hardware prevents them from changing to another provider. So making sure that you have open protocol monitoring devices within the heat network is a risk, something to be aware of and avoid. You want it to be open protocol. You don't want to be tied down. The last and most important risk on a heat network is hidden inefficiencies. If you are not monitoring, you can't see what's going on, and therefore inefficiencies can creep into the system, and you can lose your carbon savings, and the system can become quite expensive to run if you can't see what's going on. Here we did some work with BASE and found that on average, heat networks were delivering 30%, 36% of their input energy as useful heat. They were designed to deliver at 80% or more. So these wonderful heat networks that have the potential to save energy, lower carbon emissions, and be cost effective to run were not delivering. And it was a 44% shortfall against their design parameters. And this was because the systems weren't monitored. If the system is monitored, you can spot the inefficiencies. Where there is a problem, you can identify it and therefore fix it quickly. We have seen over the 10 years of working in heat networks that it doesn't take very much to destroy the inefficiency of a heat network. If someone has gone and done maintenance on the heat network and left a bypass open, this can cause significant problems, reducing the efficiency of the heat network. If you don't know that that has happened because you can't see the performance data of your network, then that inefficiency will carry on and it will have a dramatic effect on the operation of that heat network. We have some data here from a real system. You can see the flow temperature at the top in the dark blue. You can see the return temperature in the green, and you can see the flow rate or the load required in the light blue at the bottom. This is a healthy system. This is what a healthy system looks like. You have a nice gap between the flow temperature and return temperature, no matter what the load is telling us is going on. So this is what you want to see when you're looking at your data analysis from your heat network performance. Here you can see a system that is not performing very well. So again, you have your flow temperature in dark blue, your return temperature in green, and the load in the light blue. And here you can see that the flow and return temperature, the dark blue and the green, are basically running together. There is no difference in temperature or delta T between the two. If you don't have a large delta T, then your system is not running efficiently, and this will cause you problems such as high costs of running and also no carbon savings. The second graph shows a system that was running successfully. You have a nice big gap between the dark blue and the green, and then towards the end of the graph on the right hand side, you can see that all of a sudden the flow and return temperature collapse together and start tracking each other. And this is where the system, something has gone wrong. Because this heat network was being monitored, when there was a fault, they could see that there was a fault and go and investigate the situation appropriately. So these are the sorts of things that you can do with monitoring data. You can diagnose problems. You can see where on the network those problems are and therefore target them effectively. This reduces the call outs and the call out times, and overall reduces operating costs. So how does Guru help with all of this? Well, our focus is on monitoring. We understand the importance of making sure that you can see what's going on with the operational data of your heat network. Our data is reliable and our data is secure. We use a wireless mesh network, which is encrypted and therefore complies with GDPR personal data security, which is required for energy consumption data. We have an open API protocol, which means that switching between M&B metering and billing providers is quick and easy. We are compliant with all of the regulations and the CP1 heat network code of practice. And we can provide full diagnostics for the performance data on your heat network, as well as over a decade's worth of experience within the heat network industry. So I hope you have enjoyed the webinar today. If you have any questions, it's over to Charlotte.
Thank you, Helen. That was marvellous. Yes, we do have a couple of questions. So I will start with the first one that came in. So it was asked, is it the demand side heat interface unit that ensures the low temperature supply with the high delta T supplies high temperature direct hot water out of the tap?
So that sounds like a question about the heat interface unit and sort of which heat interface unit you should choose, or the importance of the heat interface unit that you choose. And, you know, it's an essential piece of kit. So picking the right heat interface unit is important, and it is the mechanisms within the HIU that govern what's happening. So you have valves within the HIU which you set to the temperature that you want your heating loop to run at, and also your domestic hot water output to be at. Also, the way the heat interface unit functions will also determine its efficiency at stripping the energy from the primary side supply. So with a good HIU, you will be feeding it 60-degree hot water from the energy source, and it will be able to strip out 30 degrees, you know, lots of energy from that primary supply and send it back to the energy center at a low temperature, such as 30 degrees. And all of that happens within the HIU itself. So I hope that answers the question.
Wonderful. Secondly, we have a question about some larger sites. So would large sites like hospitals or university campuses with existing BMS need a monitoring solution that integrates the wider heat network?
Yeah, so BMS typically doesn't monitor a heat network. I am aware that BMS companies have for some years been developing heat network monitoring modules, but they are an add-on, bolt-on module for the purposes of monitoring. The tricky part is the data analysis. There is a distinction between consumption data and operating data. And it is the analysis of fine-grained operating data that can be quite overwhelming, and BMS isn't necessarily designed for it. So really that is to go back to your BMS provider and talk to them about it. Also with BMS, my understanding is that frequently they are a hardwired system. And so retrofitting to BMS can be quite challenging. So this is where, you know, the wireless nature of Guru is very applicable. You know, there are heat networks, you know, that have been running for a number of years. The monitoring compliance changed. They used to be bulk monitored, you know, bulk metered. So basically the cost for running the system was simply divided by the residents, and it wasn't based on their consumption. This isn't allowed anymore. So there's lots of housing associations that have to go back and retrofit monitoring and metering solution on those systems. And obviously, if you're trying to tie that back into an existing BMS with wires, that's going to be a hard work.
Mm-hmm.
whereas a wireless solution would be potentially better.
Yeah, amazing. I was going to ask you what your thoughts, what you think the potential impact for Ofgem coming in as a regulator will be for heat networks.
Well, hopefully Ofgem will provide consistency. You know, they will solidify standards. At the moment, you know, the energy billing and metering regulation is the only thing that people have to comply with.
Mm-hmm.
You know, CP1 is all well and good, but it's a best practice, not mandatory compliance.
Right.
And I think this is where Ofgem will be able to come in and make sure that everybody is doing the right thing consistently.
Mm-hmm.
And yeah, that would be it.
Amazing. What do you think is the most challenging part of establishing an efficient heat network?
What is the most challenging part of establishing the, well, I mean, you know, the first place to start is the design.
Mm-hmm.
When I started working in heat networks, it was a challenge to get building design to be 70-40.
Mm-hmm.
You know, now we are, some years later, we are pushing a 60-30 design. It's all about the design. If you get the design wrong, if you oversize the pipes, if you oversize the pumps, if you know, don't apply diversity factors and all of these things, you're setting up the network to fail. I think this is a lesson that has been learnt and is potentially not so much of a problem, but that's the place to start for making sure that your heat network has the potential to function. And then the second thing is keeping it functioning. You know, system drift is a real problem. You can install a fabulous system, you can do acceptance testing to make sure that what you've built does what it was designed to do. But over time, you know, pipes can silt up, pumps can reduce in efficiency, well-meaning maintenance people can change things, and you know, this causes the system to stop functioning efficiently as per its design. And that's where the monitoring of the operation performance is critical in maintaining a heat network running efficiently.
Mm-hmm. Another question has come in. How frequently do you get the data from monitoring sensors?
Well, yeah, so I think that's kind of up to the people looking after the system. So mm-hmm. For operation performance, you're looking at 5-minute data so that you can drill into that data and see what load is happening when. So are you looking at a domestic hot water load? Are you looking at a load when the system is in standby, or is this a space heating load? So with 5-minute data, you can delve into the operation, what's going on and when. Consumption data or billing data isn't normally sufficient for such good analysis because it's half an hourly data.
Right.
So this is every half an hour, the system operation is read, as opposed to every 5 minutes, the system operation is recorded.
So there could be something missed in between that 5 minutes and 30 minutes, and you're not getting the full picture there.
That's right. I mean, you know, typically, I mean, that's not the case in my household, but typically, you know, people take showers for about 15 minutes.
Right.
You know, you might miss that. And if you're having a problem with, you know, if somebody's turned the set point within the heat interface unit up, so it's delivering 60-degree hot water instead of the 50 degrees that it was designed to, you won't see that that's what's happened because you'll miss that load operation
right.
in a half an hourly soundbite.
Mm-hmm.
So that's why you need the fine-grained 5-minute data for true performance analysis.
Amazing. That is it for questions. So we've finished early. Everyone is released. Thank you very much for attending. We appreciate all of you being here today. And we will be circulating the recording of this webinar with some additional resources and links for you to enjoy afterwards. Thank you very much all.